Hello friends, very good morning. Myself Professor M.H. Annaya, and in today's video we are going to discuss about the design of a journal bearing. Friends, the problem I have selected for today's video is such a nice problem, and by going through this problem carefully, I am very sure you will be able to solve 90% of all the questions on this chapter journal bearing, because it involves all the information designed for this journal bearing. So the question for today's video reads as a 75 journal bearing, 75 millimeter dia. So length of the journal bearing is 75 diameter is also 75 supporting a load of 12 kilonewton, and the speed is given. And he says, assuming d by c equal to 1000 and an oil having viscosity of 10 centipies, is asking us to find out the coefficient of friction, the heat generated, and the temperature of the bearing. These three parameters are asked. And friends, in this chapter or in this problem, we are going to make use of almost all the equations related to journal bearing. So let us commence the problem from the first part. The first part, you got A part in that. Find out mu, the coefficient of friction, by Mackey's equation. Friends, so we will start from the first part. I want to find out mu by Mackey's equation. Mackey's equation. Friend, this mu is given by this formula 2 pi square eta n dash by p 1 by psi 10 to the power of minus 10 plus delta mu. This is the equation of Mackey's, and this equation is available in the machine design data handbook. This is Ka eta n dash by p 1 by psi. So this is available in MDH and the chapter design of journal bearings. Friends, we want to find out what is this mu using the equation. So this Ka is a constant. This is given by the value 1.95 into 10 to the power of 11. This is given just below this equation. And friends, eta is the viscosity that's given by 10 to the power of minus 3 into eta 1, where this eta 1 is viscosity in centipi, Cp, centipi. And that is given as ton in the question. It is ton Cp, 10 centipies, Cp. So friends, we will find out what is this eta then. Therefore, eta is equal to 10 to the power of minus 3 into this 10, that is 10 to the power of minus 2 Pascal second. So you should be very careful regarding the units used in this, friends. Friends, next comes the term P. P is the pressure. So this is given by W by LD. So this W is the load the bearing has to sustain or withstand. So this is 12 into 10 to the power of 3 divided by L and D. L is the length of the bearing. That is given to be 75 So 75 divided by 1000. This has to be converted to meter. Similarly, the diameter is also 75 divided by 1000 to convert that to Newton per millimeter square or meter per. So friends, this value of P after simplification works out to a value 21.33 Newton per meter square, because the value of L and D are converted to the meter, and hence you get that value. Friends, you have a term called 1 by psi. This psi is given by C by D, where C is the diameter clearance and D is the diameter of the journal. So friends, the question is taking D by C equal to 1000. So he has given 1 by psi. Therefore, 1 by psi is equal to D by C, that is equal to 1000 given in the data. So we know this value. And this delta mu is called correction factor for end leakage, and its value for a range of B equal to or L by D ratio 0.75 to 2, its value is 0.002, 0.002 is a constant. So friends, we will substitute all these values and get the value of this mu. So after substitution of these values in the equation of Mackey's, we get the value of mu, coefficient of friction using Mackey. So mu of Mackey using Mackey's equation is equal to the value of mu Mackey's is 0.004742. 0.004772 is the value of mu using Mackey's equation. Friends, in the same question, the second part is asking what is the value of mu using Petrov's equation. So there is a separate equation of Petrov's, and the coefficient of friction using Petrov's, I will say mu by Petrov's is given by the formula 2 pi square eta n dash by p into 1 by psi is the value of the equation for the Petrov's. Friends, let us substitute the values. It is 2 pi square, eta is 10 to the power of minus 2, n dash is the speed in RPS. So speed of the shaft is given to be 1800 RPM. So 1800 divided by 60 will give you 30 RPS, the speed in seconds. So 30 I will substitute here, divided by P. The value of P already we have taken 21.33 into 10 power 5. 21.33 into 10 to the power of 5 is this value, eta n dash by P multiplied by 1 by psi. 1 by psi is 1000, that is given in the question. So into 1000. Friends, if you simplify, you get this value using Petrov's equation as 0.002726. 0.00276 is the value of coefficient of friction using Petrov's equation. Again friends, this equation is available in machine design data handbook. You can refer to that and obtain the value. And friends, if you just observe the value of mu obtained by Mackey's and that of the Petrov's, there is approximately the difference is 0.002. Here is 0.0476 and here is 0.00276. So this Petrov's equation does not take into account the effect of end leakage, which is 0.002, and hence you are getting a value slightly lesser than that obtained by Mr. Mackey's equation. So we have found out the value of mu using Mackey's equation in part A. In part B, you have found out the same using the Petrov's equation. There is one more equation to find this coefficient of friction, that is by using Raimondi and Boyd curve. So friends, there is a graph in the machine design data handbook, and here Friends, you have got a plot. In the plot, you have this B by L ratio. I'll tell what it is. And on the y-axis is plotted mu by psi on the y-axis, and on the x-axis is plotted S. That is the S is called the Sommerfeld number or bearing characteristic number, and that is given by eta and dash by p multiplied by 1 by psi. So what do we do, friend? With the available data, we will find out what is this, and exactly for that value write a vertical line till it reaches this B by L. I'll tell you what it is. And then once you have this S value and the value of this B by L ratio, you can arrive at the value of this mu by psi. Psi is known to us, so mu will be psi into that value. So friends, we have to calculate what is this bearing characteristic number or Sommerfeld number. So friend, this S is eta. Eta is 10 to the power of minus 2, n dash is 30, and the pressure we have already calculated is 21.33 into 10 to the power of 5 is the pressure, and this 1 by psi is 1000. So if we simplify this value, we are going to get as value 0.004. 0.004. So we have got this value of S as 0.004. So at that you should write a vertical till it touches the curve B by L equal to. What is B and L? Friends, B indicates the length of bearing along the direction of rotation, and this is given by pi d beta degrees divided by 360, and L is equal to the length of the bearing, that is the length L. So friend, this is pi into 75 into pi d beta, 360 degrees for a full journal bearing divided by 360 multiplied by the value of this 75, the length of the bearing. Friends, if you simplify this, it works out to approximately pi, that is 3.14. That is, the ratio of B by L is 3.14, and the graph you have got a value B by L is equal to 3. This is B by L ratio equal to 3. Now, we have calculated S, and we have erected this vertical line passing through that till it touches B by L equal to 3, and get the value of this mu by psi. And friends, this is a value mu by psi, it works out as 4. So you can write down corresponding to B by L is equal to 3.14. I'll write down here. So I'll write down here corresponding to B by L is equal to 3 approximately, comma S is equal to 0.004. We get mu by psi is equal to 4, or mu is equal to 4 times psi. So 4 times 1 by 1000, that is equal to 0.004. So friends, this is the value of mu obtained from Raimondi and Boyd curve. Raimondi and Boyd curve. And friends, you should remember this Raimondi and Boyd curve is only used for a square bearing. Only if L is equal to D, a square bearing, we are going to use this Raimondi and Boyd curve. And friends, you have seen the 3 methods of finding out mu. One is by Mackey's equation, the second by Petrov's equation, and the third is by Raimondi and Boyd curve. So these are the 3 methods or the equations used to find out mu. Next, friends, let's move on to the second part of the question. See, in the second part of the question, he is asking you what is the heat generated and use the value of mu obtained from Mackey's equation. Friends, second part is part B. You have to find out heat generated. Heat generated, and we designate it as Hg. Friends, in the book it is given Hg is equal to mu W V. So many watts. Friends, this mu he says find out heat generated using, because you got three different values of mu. Use the value of mu obtained from Mackey's. So I will say this is mu of Mackey's. W into V. What is this mu of the Mackey's? We got 0.004742 is the value of this mu. W. So P is equal to, friends, P is equal to W by LD, and hence the value of W will be P into LD. P into LD will give you W. So friends, that W will be equal to how much? 12 kilonewton. 12 into 10 to the power of 3 Newton. Then velocity is pi dn by 60. So pi into diameter is 75 by 1000 millimeter, that according to meter, and then pi d n is 1800 rpm, pi d n by 60. Friends, you got mu of Mackey's, W is the load, 12 kilonewton, convert to Newton, and this velocity in meter per second. Friends, this value of Hg works out to a value 402.25. 402.25. That's a watts. So this is the amount of heat generated in the bearing. Friends, we also have an equation to calculate what is the heat dissipated or removed from the bearing. So the third part, we have been asked to find out what is the heat generated. Determine the probable surface temperature, assuming that the heat generated is all dissipated. Friends, in this journal bearing, we have got heat generated and heat dissipated. If the amount of heat generated is more than the dissipating capacity of the bearing, then if it is more, you have to have some methods of artificial cooling. If Hg is equal to Hd, or the total amount of heat generated is completely dissipated, then no artificial cooling is required. And thirdly, if the amount of heat generated is lesser than heat dissipated, there is no need to provide any artificial cooling. So you have to provide artificial cooling only whenever the heat generated is more than the heat dissipated. And friends, in the third question is asking, third part, determine the probable temperature of bearing, assuming that the heat generated is all dissipated in still air at a room temperature of 21 degree. So we will say part 3, question number 3, we will say Hg is equal to Hd, because no artificial cooling is provided. No artificial cooling is provided, and whatever the heat that is produced is totally dissipated. Heat generated, heat dissipated. Friends, heat generated already you have calculated as a value G 402.25 watts, HD is given by the formula Ca Tb minus Ta. This is available in MDH. The amount of heat that is generated or dissipated in the bearing is given by Ca into Tb minus Ta. Friends, here this constant C is given in the handbook as 9.6 into 10 to the power of minus 3 kilowatts per meter square Kelvin, and that can be converted into 9.6 watts per meter square Kelvin. This is the value of C to be substituted in the formula, and capital A is the area of bearing. That's given as 25 times LD or DL. Again, this is given in the machine design handbook. So this is 25 times, length is 75, diameter is 75, convert them to meter by dividing by 1000. So you will have the value of A. So you know A, C you know, A is known, TB is the temperature of the bearing surface, that is TB to be found out. TB to be found out. TA stands for the ambient temperature, or that is room temperature, and the value given in the question is 21 degrees Celsius. So this is 21 I will put. So TA is equal to 21. Friends, if you observe this equation, I am equating Hg and HD. Hg already you have calculated, and HD, the heat dissipated, is given by this formula Ca Tb minus Ta. The value of C is also given. Area of the bearing housing is 25 LD or 25 DL. We have been asked to find out Tb, given this Ta equal to 21 degrees Celsius. Friends, if you substitute the value of all these Ca, Ta, etc., you will be able to obtain on calculation the value of Tb, the bearing surface temperature. Tb is equal to a value 318.96, 318.96 degrees Celsius. This is the bearing temperature, the final part of the question. Friends, please remember, this is a very, very important question, and this question covers all the design aspects of the journal bearing. If you know this thoroughly, I think you should be able to work out any problem on journal bearing. Friends, I hope the presentation was interesting. Please go through the complete video, and if you like this video, do share with all your friends. Have a wonderful day, and I thank you very much for watching my YouTube video.